this example, I'm going to show you how to perform a hypothesis test for the population mean by hand without using the calculator first and using the critical values method. A shipping firm suspects that the mean life of a certain brand of tire used by its trucks is less than 39,000 miles. So I don't see the 39,000 here. Let me just type it in. To check the claim, the firm randomly selects and tests 18 of these tires and gets a mean lifetime of 38,350 miles with a standard deviation of 1,200 miles. At alpha equals 0.05, test the shipping firm's claim, round the test statistic to the nearest thousands. Okay. There are 5 steps, guys. The first step is to state the null and the alternative hypothesis, and it is about the mean. So you begin with this: HO, HA. It's about the mean and the mean. We want to check that the mean is less than 39,000. So this is 39,000 miles here, and this is where the claim is. Okay, for the null hypothesis, it's always the equal sign, so you put what? 39,000. The alternative hypothesis must have a less than, or greater than, or not equal to. Not the 3 of them, just one. How do you know which one? It depends on what the problem says. The second step is to calculate the test statistic. The test statistic is called T0, and it has a formula which I will provide you with the formula on the test, which is x bar minus the mean divided by s over square root of n. X bar is the sample mean, it's right there, which is 38,350 minus the mean. We assume the null hypothesis is true for now, and we see what kind of results we're going to get based on this assumption. So it is 39,000. And then we divide by S, which is 1,200, over square root of n, which is square root of 18. Be very careful when you calculate the test statistic. If you input this into your calculator, make sure to enclose the numerator values within parentheses, and the same thing for the denominator. And if you do the right math, you're going to get 20 to 3 decimal places is about negative 2.298. Okay. Number 3. This is the third step now. We're going to sketch a diagram to show the rejection region of HO and the non-rejection region of HO. The whole problem is about whether we reject HO or we fail to reject HO. Now, how we're going to figure this out? We're going to use this value that we got in number 2 to make this decision. So I'm going to sketch the region right now. So it's going to be like that. This is the T-curve. Okay, now we have to decide, is it a left tail test, right tail test, or two tail test? Because it is less than, it's a left tail test, so you just do this. You shade this region right there. So the region to the left is the rejection region. We need to find this value, which is called the critical value. This critical value separates 2 regions. The one that I shaded is where the region where you reject HO, and the other one is where you fail to reject HO. Now, how do you find the critical value? You have to go to table 7. And you need 2 values in order to find this critical value. You need the degrees of freedom. The degrees of freedom is the sample size minus 1, which is 17. And you need alpha, which is 0.05. Now I'm gonna switch to table 7 and show you how I would find the critical value. Okay, this is table 7 now. I like you to watch here. Alpha is 0.05, so from 0.05 I'm gonna try to draw, this is, you draw a vertical line right here. And then 17, look where 17 and 0.05 meet. Would you guys agree that it should meet right there at this value right here, 1.740? So this is the value where 0.05 and 17 meet. Now, this table gives us positive critical value because it's area in the right tail. But if it is an area in the left tail, all you have to do is change the sign of this one. So our critical value here, it's the 1.740, but a negative value. So I'm going to go back and put it in there. So our critical value, guys, is negative 1.740. Now, how do we make a decision to reject the null hypothesis or fail to reject the null hypothesis? We take this T0, which is negative 2.298, and place it on the number line right here. Well, you guys, you would agree that this value is going to turn out to be right here because it's less than negative 1.740. Well, if it is placed right there, and this is the shaded rejection region, so you would reject the null hypothesis. So we would write, so we reject HO. Now we have to write the interpret our decision in the terms in the context of the claim. We rejected HO and the claim is in HA, so we support HA, we accept HA. How do we write this down? Let me show you how we write this down. We write, there is enough evidence at the 0.05 level of significance to support the firm's claim. What is the claim? You can write this down, that the mean lifetime of a certain brand of tire that they use on their trucks is less than 39,000 miles. That means their suspicion is right. They have a case. They can go back to the company where they buy the tires and tell them, well, you've been telling us maybe the tires do more than 39,000 miles, but what we found out that their average lifetime is less than 39,000 miles. So this is how we do the work by using critical